Okay, right. So today's session, or last session, we learned how to do the derivative of exponents. Today we're going to do the derivative of the log. Okay, so we're going to find what's d ln x to dx. And maybe just a quick reminder now, what is this ln x or ln x? It's basically the log of x basically. Okay, it's what we call the natural logarithm. Okay, you've been doing it now because you're doing calculus. Before calculus, I think you're doing logs. So you've done logs already.
We did logs at the beginning.
In the beginning, maybe, yeah.
Yeah.
Okay. Right. So before we actually calculate it, we're going to calculate it using first principle. But before that, sometimes it's worthwhile looking at. Let's do it like this. Let's try and find out what the graph looks like. So to find out what the graph of the gradient looks like, we're going to start by finding what's the gradient of log x. So let's just draw log x first. I think, yeah, we're going to need it here. So let's do it like this. Okay. So this is going to be x, and this is going to be log x. What does the graph look like? What does a log graph look like?
It's like a tilted.
Correct. Okay, so it goes up like this. Okay, it goes down, it dives down to minus infinity, but it never really crosses the y-axis. Yeah, it doesn't have an intercept. It's a vertical asymptote, and here it's not a horizontal asymptote. It keeps on going to infinity. Keeps on going. So this is log x to x. So let's try now together plot the derivative of that. Okay, because that's what we're interested in, the derivative of this. Okay? Okay, so what happened as we're moving, as x gets bigger, what happens to the gradient of this graph? What happens to the gradient? It gets smaller. So it goes down. So this graph, whatever it is, it decreases. Okay? Now, let's start from, by the way, it's only defined, those two graphs are only defined for positive x. We don't have, or we can't put a negative x in the logarithm, in any kind of logarithm, right? So, where is, how should I say it? Okay, so it gets smaller. You said we have a graph that gets smaller. Is the gradient always positive, sometimes negative?
Always positive.
It's always positive. So it starts from a value which is very high. Here, the closer I get to 0, this gradient is very high, and it slowly decreases. Does it ever reach 0? No, because we just said that this is not a horizontal asymptote. So it carries on going up, the gradient decreases, but it's always positive. So, but it gets smaller and smaller. Okay? So what we get is a graph like that. Okay? We start, if I go closer to 0, it becomes steeper and steeper. As I get closer to infinity, it gets closer to 0, but never really reaches. This is the graph of the gradient. This is x, this is the gradient of log x. Now, that kind of graph you have seen. Correct. Well, let me just pause here for a second. Okay, so as we had a discussion now, what was the exponent? Okay, exponent. You were thinking about negative exponent, maybe e to the x minus x, but that does cross. It does cross the y-axis, so it's not that one. But what this graph is, 1 over x. Okay, hyperbole. Only thing is, the only difference is that we also have another part of this graph over here, where here we only have that part. So this is actually the answer. Okay, the derivative of log x to x is 1 over x. Okay, now let me just pause here and see that you can see it in the photo. Okay, so now you can see it, and also just to answer Rachel asked me, where did the E disappear? And it's gone. It's actually gone. Now, I haven't proved it yet. I just tried to convince you by geometrical thing, and that's part of your growth as mathematicians. You're starting to develop, to connect between graphs, derivatives, and function. Okay, so by asking ourselves questions about the derivatives, okay, we created this picture of the derivative, okay, of the function, the derivative of log x, and then by saying, oh, I remember that, that looks a bit like 1 over x, but as I just told you a second ago, that could be 2 over x, okay, so, or e over x, so there's no proof here, I haven't proved it, I will prove it now, okay, so again, I'll pause for a second. So to calculate that, we're going to use first principles, but first of all, we're going to do a little trick. We're going to, let's define, well, not define, I mean, the function that I'm trying to do the derivative is y. We'll call it y, and that's, let's say, is log x. Okay? Now, yeah, so we are going to do a trick. What I'm going to do, I'm going to say, if I use that as the exponents, e to the power of y, that will be equal to e to the power of log x. Is that right? What I want to do? Yes. Now, I'm going to switch sides here. I'll put the e to the power of y here. Now, this is a really important thing for you for logs, for core maths as well. If I do, and bear in mind, this base here is e. And normally we don't write it, but I'll write it here. What is e to the power of log x power base e? X. And that's the hardest thing in logs, but it's probably the most important thing, because remember, log is the inverse function of the exponent, and vice versa, exponent is the inverse function of log. So what am I doing here? I'm saying, okay, I'm going to take, this is going to send me from x to a certain function, and then I'm doing the exponent, which is the inverse function. That brings me back to x. Okay, so e to the power of log x base e, that's simply x. Okay, all right, what I'm going to do now is do the derivative of both sides. So I use that. So I'll do dx to dx, which is a bit weird. I'm going to do the derivative with respect to x on both sides. And then I'll write it down again, d to dx of what I have here, which is e to the power of y. Okay? Now, why did I do that? You'll see in a second. So what is the derivative of x with respect to x? This is like too easy that you won't see the answer straight away. It's 1. It's 1. So look, like, let's say I have y equal to x, a certain function y equal to x, and then I'm saying, okay, what is dy to dx?
Yeah, it's
just 1.
X to the power of 0.
Yeah? I told you, this is like almost too easy that you get confused here. So dx to dx is what? What is the derivative of e to the power of y with respect to x? And this, Rachel, you won't know that because that's what we learned last lesson. So that's the one thing that you do need to know. So Olivia, all the pressure's on you. So I'm going to pause here. I'm going to pause. Okay, so I just added here to make it clear that y is not just any variable. It's a variable that depends on x. In fact, I know how y depends on x through this, but I'm going to leave the log. I'm not going to write it again log x here. I'm doing the exactly opposite. Okay? So last lesson we learned how to do the derivative of an exponent function with respect to x. And what we got is that it's simply going to be the same function. Okay, that's what's so cool about exponents. When you look for their derivative, it's the same function. But because I have to use the chain rule, I have to multiply it by the derivative of that function y. Okay, so you listen to the last video and we will figure it out. Okay, so what I got is 1 equal y prime, the derivative of y with respect to x, e to the power of y. Now, I'm almost there. Okay, what am I actually after? Sometimes maths you forget. What am I after? I'm saying, okay, this is a certain function, log x, and I'm looking for the derivative, right? That's why I'm the derivative. So now I'm going to rearrange it. All right, right. The derivative of y is simply, let's write it like this: 1 over ey. I'm not going to even write the function. just like that. Okay? And now what I gotta do is just instead of EY, write down what is EY. Oops. What is EY? E to the log x. Yeah. Why am I getting a bit lost? Okay. So let's write it down. So EY is 1 over, okay, e to power log x. Okay. And now I'll rewrite that here. Okay. That means the derivative of y. Okay, I asked you that earlier in the lesson, so hopefully now you can get it. What is exponent e to the power of log x? Remember, this is the same base x. X. Okay, so we define a function that is simply log x, and now we calculate the derivative, and we got 1 over x, which is the claim that I gave you earlier with just drawing graphs. Okay, cool. Let's pause. Just a little remark before I raise this, okay, because I know it does look like this thing is y. This is y as a function of x. It's not 1 over x. Okay, I can get rid of that x as well, just to show you it's y. Okay, it's not 1 over x. Okay, again I'll pause here and get rid of it. Okay, so before we go actually move to the example, there's one thing we haven't learned and we're not going to learn. Okay. So that was always with a natural logarithm. The question is, what about if I want to find what is the log base 5 of x? How do you do a derivative with respect to x? And the good news, guys, you don't need to know. Not important. Okay, we're only working with base e. So one less thing to worry about. But what you do have to worry about is, let's say, what happens if you have, and I'll write it here. Let's say I have a log of f of x, and I want to find out the derivative of that. Okay, so instead of just have the x, now I have a function of x. And I reckon you guys can figure it out. Okay, you guys can figure it out. I'll get it started, and then you tell me what the first bit to do. So what happens to the x here? When I do the derivative of the logarithm, what happened to x? It was just 1 over x, right? So now if instead of having x, I have f of x, what will I have at the denominator? Exactly. F of x can be any function, okay? So maybe I should start with an example. Let's say I've got, I want to find out log 5x squared, okay? And I want to find out the derivative with respect to x, okay? So this is what I'm trying to find out. Maybe let's just do that. Forget about this f of x, it's too general. So I've got a function, I want to find out the derivative of that, okay? If I just had x, the answer will be 1 over x, the derivative, yeah? So now what are you telling me, Rachel? What will I have? It will be 1 divided by 5x squared. Whatever here, it shoves it down, okay? But there's one more thing I need to multiply it by. And I think, if you think clearly, you'll realize what I need to multiply it by. Okay? I've got a function of a function. Okay, I'm not going to use the chain rule. So I need to time it by of that thing, which is, in this case, 10x. Okay, so the answer is 10x over 5x squared. In this case, what is it? 2 over x. Okay? Is that right? Yeah. So, maybe more important, what will be, I just want to make sure, yeah, what will be the general formula? Okay, so this was for a specific f of x, 5x squared. What will be the derivative here? That's it. So I'm going to even write it here, time the derivative of x. Yeah? Okay, cool. Let's do some examples. Right, so let's start with these two examples, and I'm using different notation. You remember what this capital D with the little x means? Let's find the derivative of this thing with respect to x. Instead of writing small little d, all of that divided by dx. So I need to find the derivative of that. Okay, so what I can do, there's two ways of doing it. I'll start with one. Will I do it like that, or will it be easier, I think? Yeah, I guess I can do it. Yeah, all right. So you guys tell me, okay, what's the other ways, but let's just do it like that. So, yeah.
One of the function.
One of the whole thing, x squared minus 3x plus 1 times,
The derivative of the function.
and what's the derivative function? If you don't mind, I'll just write it on top here, yeah, you understand? Yeah.
2x minus 3.
That's it. Pretty easy, isn't it? Okay. Okay. Now the next one step up. Okay, so I've got this function, log of x plus 1 divided by 3x minus 4. And again, I want to find the derivative. Now, the hard thing to do, I'll start with the hard way, but then I'll change course. Okay, so one way of doing it, exactly as we do here, is to just do 1 divided by x plus 1 divided by 3x minus 4. Right? But then I need to multiply it by the derivative. But check out, the derivative of what? Of this fraction. And so we got to use what we call the quotient rule, which is, it's a nightmare. It's a nightmare. So let's not do it. Okay? I mean, it's not a nightmare. It's totally possible, but there's an easier way. And the easier way is to use log rule before. And again, this is something you also did in core maths. So when you have a logarithm of
log x plus 1 minus.
That's it. You can split it into x plus 1 minus 3x minus 4.
And then you use two separate.
Then you just do the derivative of that. The derivative. So you see, you've got to be clever about this, right? So the derivative of this will be 1 over x plus 1 times the derivative, which has nothing, is 1, minus 3x minus 4, and now I need to multiply it by 3. So I think that's the answer. Yeah, that's the answer. Okay, I'll just pause here. All right, so now a question which is a bit longer. All right, so they're asking us to find the gradient of a normal to the curve y equal log x cubed minus 5 at x will equal 2. So normal, if you remember, there's going to be something about multiplying by something, or the minus 1, isn't it? You know what I mean. We'll get there in a second. And we get the x. So the first step, as we've been doing, is find the derivative. Okay? So, I mean, let's actually look at the whole question first. Okay? So you've got a curve. Okay? So this is that curve. Y equal log x cubed minus 5. I don't know, I just drew it. I don't know what it looks like. Now we've got a certain point, x equal 2, and then we've got a normal to it. So that's the normal, we'll call it A. And the normal is 90 degrees to what? To the tangent, we call T. So once we know what's the gradient at this point, okay, then I know that the gradient of the tangent times the gradient of the normal will be equal to minus 1. Okay? Remember that one from analytical mechanics, yeah?
So that isn't a tangent, or it is.
Yeah, I mean, it doesn't look like it. Yeah, it shouldn't cross. Well, it will cross, but it doesn't cross here. It's just because that graph goes down. If not to confuse you, let's say the curve looks like this. Okay? Now you'll be...
Tangent can cross.
Well, it doesn't cross on the point, but for example, I don't know what. If I have... It could cross eventually. Oh, you know what I mean?
Yeah.
It just doesn't cross on that point. So yeah, the way I drew it was not very good. Yeah, we'll do it like that. And then it crosses eventually. Okay? Alright. Yeah, it doesn't cross. You shouldn't cross. It just kisses it on that point. Okay? Yeah. Alright. We need to first of all find the gradient here. How are we going to find the gradient here? We're going to find the formula for the gradient. Okay? So y prime, can you tell me what will be the derivative of that?
3x squared.
Okay, so you already put you put the derivative, the inner derivative or derivative of the inner function on top,
Yeah.
great, and divide it by
3x cubed minus
x cubed minus 5, and then that's it. Okay, now we want to find out what the gradient at that specific point where if x equal to.
So you just sub it?
Sub, just sub, easy, okay? So 3 times 2 squared divided by 2 cubed minus 5. How much is that? 3 times 4, 12. Divided by 3, just please check me. Notorious for making blunders, yeah? I got 4.
Yeah.
Okay? So the gradient of the tangent, m of tangent equal 4. That means m of normal will be
Minus 1 over 4.
minus 1 over 4. And that's what they got, so we must be right. Okay? Now, obviously, if they were mean, they can extend the question. What could they ask here? So we found the gradient of the normal.
Well,
What?
they want the equation.
They want the equation. So let's just think, not do it, but let's just think how are we going to do it. Now, I've got the gradient.
Yeah, and then you just sub in.
Sub in
X equals 2.
x equal to, how do I know what the y is?
You use the formula.
Which formula?
Y equals that.
That's it. So I substitute 2 here, get the y, so I know what the y is. Substitute it in mx plus c, you know that story. Okay, cool. Right, so to finish up, I've got these 3 questions. Just simple calculation of derivative. Simple, but not necessarily short, okay? So we're going to use the rules that we spoke about. Chain rule, quotient rule, product rule. So I've got, this is a product rule, okay? That time that. So I've got to find, so if I want to find the derivative, okay? The derivative, I'm going to do the derivative of the exponent. So live here, that's you, because Rachel wasn't here last time. What will be the derivative of e of x?
It's just e.
X. That's it. And I multiply by log 2x minus 1. Okay. Plus the function, the first one function, times the derivative of the second function. So what will be the derivative of the second function? I'm going to, what happens to the 2x minus 1? Yeah, so I get time 2 at the top, and the 2x minus 1 goes down. Okay, so we can rewrite it a bit nicer, plus 2ex over 2x minus 1. Okay, not very nice, but that's what we do. Okay, all right. Okay, derivative of this one. Okay, so that's a chain rule. So, and it's a chain rule applied 3 times. 3 times. Because you got a big function which you cube it, and then you got in the function a middle gabushka log of function, and then you got the inner function which is just x squared. Okay? If this is not clear, that x squared is inside the log x. Okay? Alright, so we'll start from the outer babushka. So what happens to that cube then? So 3 log x squared. Okay? And then I need to multiply, and again I'll put like green brackets, write it here, time the derivative of this function, the log x squared. So what happens to log x squared?
1 over x squared.
So we'll 1 over x squared, correct? Time the derivative of the middle one, which is that one, which is, so I'll write it or there, yeah, 2x, and now I'll write it all nice. Will be 3 times 2, so it will be 6x. Okay, I'll put the 2x over this side. Log x squared, put brackets there, divide by x squared. Okay, I can actually get rid of x here. That's it, so it's 6. Okay?
So what happened to the derivative of x squared?
Yeah.
That was actually that.
But you times that anyway because of the derivative of lambda.
That is the chain rule. Where did that derivative of f come? It's application of chain rule. So we don't need to do it twice.
Okay.
Yeah? Okay, that came from the chain rule. Okay? Okay, we're going to use it in a second. Now, this one actually I don't want to do, because I think you can figure out, it's a little bit long. What rule are we using here? Quotient. So we're going to do the derivative of the log, okay, so it will be 1 over 4x plus 1, times 3x, that function, minus the log, times the derivative of 3x, which is 3, divided by the square root. You guys can do it, okay? I'm going to just clear out something and talk about what you asked me a few minutes ago, Rachel. Okay, so the last bit is actually nothing to do with what we've done now. Of course, it's to do with it, but it was more question here about the chain rule, whether the chain rule is in the sheet, okay, the documents that you get, and it looks like the chain rule is, but actually it looks like the product rule, the quotient rule, they're not there, okay? So not everything is there. But even the chain rule is in a different form, and I want to just explain that form. So the chain rule, the way I wrote it to you, said, let's say we have a function of a function, f of g of x. And if I want to know what df of dx, what I've got to do is df of dg, I've got to do the derivative with f with respect to g, okay? And then time it by dg to dx, okay? I might have even not written it like that. Can't really remember. You guys are going to tell me like that in a second. I might have written, okay, we'll do the derivative of f with respect to g, time the derivative of g with respect to x. I'm not sure, I'll be honest with you. This is actually not mathematically not nice to write it like that. I should really write it like this. Okay, but we basically, you know, if I had the example before, well, I can't remember what it is, so I'll just make one. So let's say I have log x cubed, and I want to find the derivative of this. D of that to dx. So what I'm going to do, I'm going to do 1 over x cubed, which is the derivative of the log, and I'll time it by the derivative of the inside, dg to dx, okay, which is 3x cubed, 3x squared. Okay, now in the formula sheet, it's written like this: dy to d or dy to dx. Let's say I have a function of, they don't write it down, so I'll put it in brackets. But let's say I had a function of y, which is a function of t, which is a function of x. Okay, this I'm going to put in brackets because they don't write it to you. Okay, if you want to know the derivative of the big function with respect to x, okay, what you got to do is dy to dt, derivative of the big function with respect to what's inside it, and time it by the derivative of this function, the one inside, with respect to the hidden variable inside it. So that's what they write for you in the formula sheet, which is the same thing really, but maybe different letters. Okay, so we need to get used to it. Okay, I'll stop here and I'll answer any question you want, but we are done really. Yeah.